Good day, everyone. Today, I will give an example for bases. But first, let's have the definition of bases. A set S is equals to x1, x2, and so on until xk, where k represent a certain number of vectors in a vector space V is called basis for V if S spans V and S is linearly independent. We must take note to the two conditions. We can say that S spans V if every vectors in V or vector space is a linear combination of the vectors in S. And we can say that S is linearly independent if all scalars are equal to 0. So to clearly understand, let's have an example. Let S is equals to x1, x2, x3, where x1 is equal to 3, 1, 2, and x2 is 1, 0, 1, and x3 is 1, 2, 1. Now, the question is the set of vectors x1, x2, x3 a basis for our cube? Please fasten your seatbelt and let's explore if S is linearly independent and S spans V. To see if the given set of vectors is linearly independent is through using or the method of linear combination. So let C sub 1, C sub 2, C sub 3 be scalars. Then C sub 1 times X sub 1 plus C sub 2 times X sub 2 plus C sub 3 times X sub 3 is equal to 0. Through substitution or substituting the value of X sub 1, X sub 2, X sub 3, we now have C sub 1, 3, 1, 2 plus C sub 2, 1, 0, 1 plus C sub 3, 1, 2, 1 is equal to 0. By that, we can create or we can form an augmented matrix. 3, 1, 2, 1, 0, 1, 1, 2, 1, and 0, 0, 0. Since our goal is to find out the value of our scalars and we already have our matrix, so we can now proceed to solve for the value of scalars. And to do that, we can use various methods like the row echelon form, the Gauss-Jordan elimination, the inverse, and so on. But for this video, I prefer to use the Gauss-Jordan elimination. So from this matrix, our goal is to make this into an identity matrix where the diagonal is all 1 and elsewhere are 0. So first step is we will make sure that the pivot is 1. So instead of 3, we will make sure that it will be going to 1. So how to do that? We will going to swap R2 and R1. By swapping that, we can now have our new matrix 1, 3, 2, 0, 1, 1, 2, 1, 1, 0, 0, 0. So as you observe from 3, 1, it became 1, 3. It's because, what I've told you, we swapped the R2 and R1. Next, since we already have our pivot as 1, then we will proceed to make the other numbers in column 1 to 0. So to make this 3 0, we will going to minus R2 minus 3 R1. 3 minus 3 times 1 is equals to 0. 1 minus 3 times 0 is equals to 1. 1 minus 3 times 2 is equals to negative 5. And we will going to copy the row 1 and the row 3. Next, we will going to make this number into 0. So how to do that?
Go.
We will subtract the R3 minus 2 R1. 2 minus 2 times 1 is equals to 0. 1 minus 2 times 0 is still 1. 1 minus 2 times 2 is negative 3. And then, copy the row 2 and the row 1. Next, as you can observe, we are already done with the first column. So let's proceed to the second column. In second column, our pivot is already 1. So we have no problem with that. And our other number is already 0. So again, we have no problem with that. So let's proceed to R3. This number 1, we will going to make this into 0. So how to do that? We will subtract R3 to R2. R3, which is 1, minus R2, which is still 1. So 1 minus 1 is equals to 0. And then negative 3 minus negative 5 is positive 2. So, copy the row 1, copy the row 2, and that's the row 3. So, now we have our new matrix again, 1, 0, 0, 0, 1, 0, 2, negative 5, 2, and 0, 0, 0. We are already done with the second column. So, let's proceed to the third column. In the third column, the pivot here is this 2. And the pivot is, or our goal is to make this number into 1. So to make this, we will going to divide R3, divided it by 2. So, like this. 2 divided by 2 is 1. Copy the row 1, copy the row 2, and then the row 3. Next, since our pivot is already 1, then let's proceed to R2. This negative 5, our goal is to make this 0. And how to do that? We will going to add R2 and 5 times R3. Negative 5 plus 5 times R3 is equals to 0. And then copy the row 1 and copy the row 3. Next, this number 2, we will make it into 0. So again, how to do that? We will going to subtract R1 to or minus 2R3. So let's have 2 minus 2 times R3, or 2 times 2 minus 2 is equals to 0. So at this point, we already achieve our identity matrix. The diagonal are 1, 1, 1, and elsewhere are 0. So at this point, we have now our scalars, or the value of our scalars. Our C1 is 0, C2 is 0, and C3 is 0. So we can now conclude that the set of vectors x1, x2, x3 are linearly independent. It's because all values or all the scalars are equal to 0. So let's check the first condition. S is linearly independent. At this point, we can now proceed to find out if S, or the set of vectors, spans to the V or vector space. So now, our goal is to answer the question, is S spans V? So let x sub 1, x sub 2, x sub 3 be the set of vectors, and x, y, and z be the set of elements in R cube, and k sub 1, k sub 2, and k sub 3 be the scalars. Then, k sub 1 times x sub 1 plus k sub 2, x sub 2 plus k sub 3, x sub 3 is equals to x, y, z. So, by substituting or substitution, the value of x1, x2, and x3, we can now have k1, 312 plus k2, 101 plus k3, 121 is equals to x, y, z. So, by that, we can now form an augmented matrix. 3, 1, 2, 1, 0, 1, 1, 2, 1, and x, y, z. Since we already have our matrix, then we can now proceed to perform in solving for the value of our scalars. So to find it out, again, we can use row echelon form, inverse, Gauss-Jordan, and so on. But still, for this video, we will going to use the Gauss-Jordan elimination. So from this matrix, we will going to swap the R2 and R1 so that our pivot will become 1. So from that, we can now achieve, or we have now a matrix 1, 3, 2, 0, 1, 1, 2, 1, 1, y, x, z. At this point, we're going to proceed to the other numbers for the column 1. We will going to make these numbers 3 and 2 becomes 0. So to make this number 3 0, we will going to subtract R2 minus R3, 1. So 3 minus 3 times 1 is equals to 0. 1 minus 3 times 0 is 1. 1 minus 3 times 2 is negative 5. And x minus 3y is, of course, x minus 3y. So we then copy the first row and the third row. Now, we will going to make this number 2 becomes 0. So to do that, we will going to subtract R2 minus 2R1. So 2 minus 2 times 1 is 0. 1 minus 2 times 0 is equals to 1. 1 minus 2 times 2 is negative 3. And x minus 2 times y. So that's it. As you can observe, we are already done with the first column. So let's proceed to the second column. And in the second column, our pivot is already 1. So we have no problem with that. Let's proceed to this number in R3. We will going to make this number into 0. So to do that, we will going to subtract R3 minus R2. One minus 1 is equals to 0. Negative 3 minus negative 5 is equals to 2. Z minus 2y, or the quantity of z minus 2y minus the quantity of x minus 3y is negative x plus y plus z. And then still copy the row 1 and copy the row 2. So as you can observe, we are already done with row 1 and row 2. So let's proceed to column 1, column 2 rather. So let's proceed to third column. To make this 2 becomes 1, we will going to divide it into 2. So R3 divided by 2. 2 divided by 2 is 1. And negative x plus y plus z divided by 2. Just simply like that. And then copy the row 1, copy the row 2. Again, our pivot is already 1. So let's proceed to the other numbers in this column. So we're going to make this negative 5 becomes 0. So to do that, we will going to add R2 plus 5R3. So negative 5 plus 5 times R1. Since our pivot is already 1, so we're going to proceed to other numbers in this column to make this 0. Specifically, the 2 and the negative 5. So, to make negative 5 becomes 0, we will going to add R2 and 5R3. So, negative 5 plus 5 times 1. So, simply, negative 5 plus 5 is equals to 0. And add x plus 3y plus 5 times the quantity of negative x plus y plus z over 2. And we'll get the answer negative 3x plus y minus 5z over 2. And then copy the row 1 and copy the row 3. Next, we will going to make this number 2 becomes 0 through subtracting R1 minus 2R3. So, 2 minus 2 times 1 is equals to 0. And y minus 2 times the quantity of negative x plus y plus z over 2 is equals to x minus z. So, at this point, we have arrived, or we have now an identity matrix. 1, 1, 1 in the diagonal and elsewhere are zeros. So the value of our scalars are k1 is equals to x minus z, k sub 2 is equals to negative 3x plus y minus 5z over 2, and k sub 3 is equals to negative x plus y plus z over 2. So, since we have now our 3 scalars, then we can conclude that the set of vectors x1, x2, x3 spans our cube. Earlier, we have proved that S is linearly independent. So, check. And now, S spans V. So, we have already proven, so it's already checked. So, since we have satisfied the two, or we have proved the two conditions, then we can now conclude that the set of vectors x1, x2, x3 a basis for R cube.